Hello and welcome back to the Oxford MAT Livestream. It's great to have you with us. My name's James. I'm the admissions coordinator for maths, and this is going to be a sort of live session where we look at past math questions, talk about the maths, do a little bit of math advice, stuff like that. Hello to people who are joining us live. Great to see so many people joining in live. Shout outs, I suppose, to people I've been talking to just before we go live. Anonymous people, Mohammed, Oscar, Len, Imogen's just joined us. Hi, Imogen. Somebody wants to know who invented calculus. I'm obviously biased. I'm going to pick Newton. Definitely 100%. That sort of thing's going on in chat. And this week, the plan is to look at, hi everyone, there you go. You can be anonymous in chat, or you can use, well, either your name or your favourite maths equation or something like that. The plan this week is 2023 questions. Hi to Matthew and Harry and Toby. There they go. Okay. There's something I normally do at the end of the MAT live streams, before the test, which is at the time of recording next week. At the end of the last one, I normally do this kind of slightly soppy goodbye message. I'm going to have a go at doing it at the start of this week. Because frankly, more people will see it if I do it at the start of the episode rather than at the end. This is going to be the last one we do before the actual test happens next week. I just want to be really clear that whatever happens in the test next week, whether you do all of the questions straight away and walk out knowing that you've got 100, or whether you can't do the questions and it's all really hard maths, whatever happens in the test, you are still you. You are still interested in maths. You are still, I reckon, probably going to go on and have a really good time at university doing lots of maths or computer science or some sort of mix of those two things. You don't change. The test might happen and change from being a scary thing in the future to a scary thing in the past. You can still go on and do amazing things. Maybe this is the bit where you get into Oxford, maybe this is the bit where you get into a different university. Either way, I think that, well, what I hope is that by thinking about tricky maths questions, I'm hoping that that's been helpful to you either way, so that however it goes, you'll have something from this. Even if we've just helped you revise A-levels, then I hope that this has in some sense been happy. Oh my goodness, look, IB, the integration Bible, is back in chat. There you go. People are coming back again for the last one. So hi to people I haven't seen for a while. Integration Bible, aren't you from last year? Are you currently a student? What's going on? Sometimes my current students drop in just to say hi. Right, is there a break? No. Wait, so if you booked an access arrangement, and it's complicated. If you booked an access arrangement, then yeah, you've got access arrangements. Tips on timing has got lots of thumbs up in chat. Tips on timing. What I was usually told about tests is to look at the questions before you do the questions. I was never very good at that when I was your age, but look at the questions before you do the questions. I was never very good at that. You might like to have a look at the questions in this test before you do the questions, which might involve looking at the multiple choice questions, deciding how you feel about them, looking at the two long questions and deciding how you feel about them, and just making a kind of snap decision what you want to work on next. I'm not sure you should go into the test with a kind of time limit for yourself on each question, because I think that's just going to stress you out either way round. Do try and have a go at all of the questions, but keep an eye on the time, of course. But I wouldn't set yourself a kind of checkpoints kind of thing. Right. Generally in the UK, format multiple choice questions ranked in order of difficulty. No comment, I'm afraid. Okay, right. Should we do the vote for how you're doing? I'm almost a little bit scared. Let's do the vote. It's the how was your day today vote. I guess it's today. Your day could have gone in multiple different ways. It's been maybe a normal Thursday for you as people vote, press all the buttons all at once. Let's see. Yeah, okay, right. Well, let's let that run. How about we do both at the same time? Is that a good idea? Kind of judge the feeling in the room. Yeah. There's a slightly staggered time. It's always been the case. So someone's asked about times for the MAT. It's always been the case that it's slightly staggered. That's why there's kind of an embargo on the MAT. You can't take anything out of the test room, and you shouldn't discuss the MAT for the rest of the day. That's always been the case due to different time zones around the world. This year, everyone's in test centres, which means it's much harder for you to take stuff. Also, the questions are digital on the screen. It's much harder for people to take things out. What stops people discussing it? Well, lots of things, some of which I can tell you and some of which I can't. There are some security measures. There's also a lot of self-interest that prevents things like that a lot. You can only do this test if you're an applicant on UCAS, which means that everyone who's doing the test wants themselves to do better than average. You don't get that if you try to help somebody else with the test. It's not an open examination. The only people doing MAT are people who are matched to UCAS applications. Right. Okay. How can you show algebraic working with a standard keyboard? Such a standard question, isn't it? Oh, somebody's put Fermat's last theorem as their username. That's pretty cool. Good. Right. Okay. People are having a terrible day on the vote there. People are having a 3.5 kind of day on average, and look at that tick up at the 10% point. That's one of the lowest ones we've ever seen. People not very happy about that. Just to answer some more questions that are coming in. We've got more people live than we've sometimes had, but that's to be expected. So we've got more questions than normal. If anybody's watching the replay on YouTube, I guess you could be watching this at double speed, or you could be skipping ahead to the bit where it starts moving around as we start doing questions. If I signed up for MAT without middle names, that's probably okay. We've probably successfully matched you to an application. When you apply, I think you get one of two automatic emails that either says you've been matched to a MAT registration, or we can't match you, please let us know what's going on. If you got one of those emails, I guess please read that email. Otherwise, if you want to make sure, you could, if you really want to, you could check that your middle name situation didn't confuse Oxford's matching process. But there's a whole team on this. It's not just a simple computer error sort of thing. Really keen on asking about algebraic working in the MAT. So I just need to be really clear that candidates are not expected to type complex mathematical expressions for the long questions on the MAT this year. You are the sort of unasking the question, really. It's sort of people are saying, how am I going to type all my complex mathematical expressions? And the answer is just you're not expected to type complex mathematical expressions. I have to say not expected, right? Because I mean, there are you can press any of the buttons. There's a keyboard. You can press the buttons, but I can't stop you. But the questions have been written such that you're not expected to type complex mathematical expressions. Ivy wants to know, if you get the final answer correct, do you get all the marks even if our working is not correct? Ivy, some of the questions are going to say explain or justify your answer. On those questions, it is really all about how you explain or justify your answer. So this has happened in the past where it might be a yes/no question, but it's always it's also a question about explaining things. Right. Okay. Primary ID. A question about ID I really can't help with because we're using external test centres, and I'm just the sort of maths person here. I know about maths. We're using external Pearson VUE test centres. Please talk to them about whatever they've told you. Whatever they've told you about ID is not my policy about ID. Right. Cool. Okay. Long question. Blah 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 blah. Good. Okay. Good. The vote thing, while I've been talking, the vote thing has gone down to 3.4, which makes me think that maybe me talking and answering questions is making things worse. Let's talk about some maths. See, there's the signal for people who are waiting for the screen to move so that they could zoom in to jump to this timestamp. Here we are. We've got a question on the board. I've switched off chat, but I can still see it. So if you're saying things, here we go. Yeah, that's just somebody's in chat's just worked out this is the paper from last year. But being how we've been doing past papers, I suppose it was coming. Right, we've got two circles inside a square. One of the circles is tangent to the sides AB and BC. The other circle is tangent to the sides CD and DA. And circles are tangent to each other. We're told a fact about the areas of the circles. the area of the large circle is 10 times the area of the small circle. The diagram is not to scale. So the question for this is, perhaps, do we put in some information about the radii of the circles, maybe? We're asked for the sum of the radii. And kind of what I want to do is label the two radii. I've done something silly there. I've drawn in lines that aren't very helpful lines. I should probably draw in lines that are helpful, for example, to a point of tangency or something. I'm not interested in random point on the circumference over here. I'm interested in points where it's actually tangent. So I'm going to try and draw my radii in that sort of way. Okay, let's take one question from chat just quickly. I've heard that some Oxford admissions tests, HAT mainly, in fact HAT only, have crashed. There was one issue with the HAT, the history admissions test. Oxford have been monitoring other tests, and at the time of recording all the other tests have been fine. If you're applying for history, then I think you might have clicked on the wrong live stream, but if you're applying for history, then there's communication from the history faculty about what's going on there. It is the case, I believe, that essentially everyone was able to do the history admissions test, possibly after some sort of delay. There's some sort of technical delay to the start of the history admissions test on Monday, but no other tests. Good. Right, okay, people in chat are giving me some maths, which is what I want. Done this question without using the area fact, unless you've done something wrong. Possibly, or possibly not. Let's find out. So let's label some radii. What shall I call them? If I'm following some anonymous person in chat, they've told me that pi big R squared is 10 pi little r squared, and they've told me some other facts about big R and little r. So what can I say from this? I think I can infer from this that big R is the big circle. Cool, you never know though, you never know. And what else can I infer? Oh, I see. So they've told me this thing about ratios, and I guess they've had some idea about drawing in maybe some other lines that are interesting. So these other points of tangency are interesting, and this point where the two circles are tangent is interesting. So we'll draw some radii over there. There's a shared, because they're circles of tangent. If you could imagine some sort of shared common tangent at that point, which means that the radii are both at right angles to the common tangent, which means it's a straight line. And you can kind of see on the picture that it's a straight line, even though it's not to scale. Yeah, come on, joining the dots. Radii, right. I feel like we've had tangent circles before. Let's do a general fact then. Whenever two circles are tangent, the line between their centres consists of two radii. Good. Right. Ooh, people in chat now talking about history. Opinions are being shared about history. Good thing chat's not on the screen, otherwise my historian colleagues might see. Right, okay. Somebody's done some geometry in chat. I think it's what we're doing. Yeah. There's a great description from an anonymous person about geometry stuff. They have spotted that we can label some more stuff, including, brilliantly, the distance in here of how long these bits of line are to get all the way from B to D along the line, which is what I want to do because the square's got side length 1, so I have this strong feeling that the length BD is something I know. So in fact, we can put this together, can't we? We can put this together. I think I'm going to get the other factor that somebody told me in chat at some point. To get from B to D, you have to go to the centre, which is root 2r of the big circle, plus r to get to the point of tangency. These are all in the same line, aren't they? They're all along the middle of this picture. And then little r to get to the centre of the other circle. And then root 2 little r. All of that is equal to root 2. And actually, we can factorise this down a little bit, can't we? This is quite nice. This is root 2 plus 1 big R terms, and root 2 plus 1 little r terms. Which, now that I look at it, gives us this fact, this sum that we want is right there. So the sum is just root 2 divided by root 2 plus 1. Which simplifies a little bit. You can try and make this look like one of the options. Spoilers, it's going to turn into B, isn't it? If I multiply top and bottom by root 2 minus 1, which is the difference of two squares sort of thing. Sort of rationalising the denominator of some surds or something to use the language. Yes, Ruby says Pythagoras. Pythagoras all the way. Kind of 3 different instances of Pythagoras. big circle, little circle, huge square. Pythagoras everywhere you look, loads of factors of root 2. Which maybe means we pick one of the options with root 2 in. It's this one. This thing is equal to that. I've changed colour. Why have I changed colour? Good. Okay, fun times. The area fact doesn't matter. It's a good question, isn't it? The area fact doesn't matter. It is irrelevant information. The number 10 doesn't matter. The answer is nothing to do with 10. There's a range where you can't set that number to be anything in the question, because sometimes the large circle is so large that, well, the diagram would be a bit different perhaps, but if the large circle is too large, then it starts going outside the square, and then I don't quite know where to draw the small circle. I guess maybe that makes sense. There's some cases I get worried about, but all of this works no matter what number I put here, which is maybe surprising. Right. Look, somebody from Twitch, somebody from Canada is in touch. Other people are doing Pythagoras. Right. Okay. Right. Mohammed in chat says I could have resolved the distance between the centres horizontally. Yes. Okay. There's an option. I like that. So I could have taken this tricky bit of distance between the centres, and here's another 45-degree right angle triangle, I suppose. Resolve it to find this distance here, or equivalently this vertical distance here. Mohammed is thinking about adding up this r going left to right from here to this bit, whatever that is. I guess it's big R plus little r divided by root 2, and then up here another bit of horizontal distance, to kind of think about it in different horizontal chunks that add up to 1. So they've probably written something like this, which is going to give us the same solution. Maybe it's a little bit more obvious that this one factorizes, so that's nice. We're going to have to do some division, aren't we? But I'm just going to do exactly the same steps from there on out. Can you request a pen and paper? My understanding is no, that you can't request a pen and paper. The test centres have certain equipment in them. Sorry about that. If you have an access arrangement that gives you pen and paper, then you've already sorted that out. Why is it necessary that the triangle has an angle of 45 degrees? Good question. There is a square in the question. That's helpful for this large purple triangle. And then there's lots of equal lengths, like this large r and this large r here. There's lots of, because the circle has constant radius, there's lots of occasions where two things are the same, either because they're two radii of the big circle, or because they're two radii of the small circle, or because they're two sides of the square. So I'm not just assuming things are 45-degree triangles, I'm noticing that they are isosceles and right-angled. Is it obvious that things are right-angled? Yeah, there's a square in the question, there's a load of right angles everywhere. Okay. Wouldn't have mattered if we wanted the difference between big R and little r. Would have mattered, yeah. The question asking for the sum is being kind to us. Oh, the blue triangle. Yeah, blue triangle, less obvious, isn't it, that that's a 45-degree angle? How am I going to justify that, I wonder? Well, possibly I'm going to say that it's looking vertically. The height of that triangle is 1 minus little r minus big R. And looking horizontally, that's also the width of the triangle. Things really turn out to be equal. I think, okay, you got me. I think on that one I might have assumed there were some 45-degree triangles going on, and that really I should have written down over here 1 minus this is equal to, and then because it's an isosceles triangle, now I'm allowed to write this thing on the right hand side. Okay. You got me. I might have assumed that one was a 45-degree triangle. In my defense, that was the fourth triangle I'd drawn, and the previous three had been 45-degree angles. Okay, good. Right. Yeah. 45 people are now. We're moving into the overkill territory, I think, for this question. Good job, everyone. Love it. If in doubt, draw a small part of the diagram, I think. Mine's got very complicated, of course. On your little whiteboards or whatever you've got, whatever that is, you might like to draw a kind of subset of the picture. to remind yourself of what's going on. So you might mark in things that you know. And sometimes when you make a small diagram like this, you kind of forget how it fits into the big picture, but sometimes this helps you realize that, well, it'd be nice if that was a 45-degree triangle, right? And then you can go back and look at the big picture and work out whether that's true or not. Right, definitely moving into this. Is it difficult to do maths staring at a computer screen? I guess I'm biased because I do 2 hours of that every week, sometimes 4, but I think I can look at maths on a screen. I think it's going to be okay. Right, okay. Bit late now for me to change my mind about how testing is working, I'm afraid. Okay. Worth asking, isn't it? Okay, right, good. Let's see, let's find out what we're doing next. The way this works is we're going to do some sort of vote. Yeah, symmetry. Wow, you've got on screen with a comment about symmetry. Which is good, yes. Love symmetry. What is that? Some sort of reflection in the line BD or something? Whatever. Okay, right, here's a vote for what we're doing next. You're in charge. I picked this one because I wanted to put it in the thumbnail. I thought it would be a good picture for the thumbnail of the video, and once I put it in the thumbnail I have to talk about it, otherwise it's clickbait. But now it's over to you. This test has got, oh gosh, I think about 15 different questions in. If you'd like to grab a copy of it yourself so that you can form an opinion about what we're doing, you could look at the Oxford MAT Live website, which has got copies of past papers. You can even find other past papers there as well, work solutions, stuff like that. So people are currently voting for example, the final multiple choice question and question 4. I'm sure there are some people who are voting for the question we just did because I put it in the poll. And there's usually someone who wants to vote for the one we already did. Right, let's have a quick look at chat as well. Chat has hit 116 messages, right, okay. We're doing all right? Symmetry is still top of chat, good, okay. 2 seconds for me to catch my breath. I've been talking non-stop for 20 minutes, but that is my job. Right, it's pretty close in the voting, but it's long questions that are doing well. We don't often talk about question 4, so maybe we could do something to a question. Like in previous weeks, we've question 4 hasn't often won up, and it's not winning this one either. Maybe I'll do it anyway. The poll is guidance to me. I don't always feel fully bound by democracy. Yeah, Ayush in chat is saying something about 45 degrees. Horizontal line that's parallel to the side of the square. Yeah, okay. Well, it seems good. Right. People are typing their explanations in chat using words. And, right, good. Okay. Somebody else asked who writes the math questions, and it's a team effort. I sometimes have some of the ideas for some of the math questions. Right. Oh, and somebody has asked about promise. If you haven't heard of promise and you're in year, oh gosh, so at the time of recording you would be in year, well, you'd be aged about 16 to 18 and you'd be somewhere in Europe, because they're asking about promise with a Y and without an E. Gosh, that's harder to sell on the radio than I thought. Promise is a summer camp for maths. Does going on promise and other maths camp help in being shortlisted? Not directly. So it doesn't count as a shortlisting criterion. The idea of this sort of summer camp is that you learn about maths and maybe have a good time and make a more confident and informed application where you know what you want and you maybe even better at solving problems or something if it's one of those summer camps. So it doesn't help in shortlisting in a sort of boring box ticking sort of sense. If it helps in a sort of news that's better for you, that it might also help you later in life as well. You'd prefer this, right? You'd prefer it to be the case that maths camps actually help you get better at maths, rather than just you turn up, somebody ticks a box, somebody else ticks a box. You don't really want that. Right, 5 is definitely winning this. Shortlisting criteria. We do actually publish these on our website somewhere. Broadly, we're looking for people who are good at maths. That's not the actual text of the shortlisting criteria. Right, okay. Question 5's won this, but question 4 has done quite well, and I feel a bit sorry for question 4. And just because they're on screen, I work at New College a little bit. I mostly work in the maths department. I'm currently in the maths department, but I work at New College a tiny bit at the moment. And no, the math and the personal statement are not weighted equally. We don't actually have weightings in the maths department for different parts of the application, but if we did, we would be much more interested in the MAT, which is a maths test, versus the personal statement, which is a writing exercise, because our degree contains lots of maths and not very much writing. Right, good. Okay, I'm turning chat off again, not because you said something, but because I would like more screen space. Oh gosh, I feel really bad now. Okay, 4 and 5. Let us do. What are we going to do then? I think we're going to have a look at a bit of 5, and we're going to try and pick out useful bits of 5. My plan for today is to try and do more questions than I normally do, if that's all right. Foreshadowing for me doing exactly one question, isn't it? I now spent the next hour and a half talking about Fibonacci numbers. Oh, observe, by the way, you don't need to have seen Fibonacci numbers before. This question is about Fibonacci numbers. I know that. I love Fibonacci numbers. Look at them. They go 1, 1, and then you add them together. And then you're going to work them out. F3 is 2 because just slow motion replay there. 1 plus 1 is 2. Welcome to the Oxford MAT Livestream. I almost missed an opportunity to tell you that 1 plus 1 is 2. And then F4, you add together the previous ones. So the sequence goes 1, 1, 2, add together the previous 2. It is a useful skill to be able to turn a statement like this, where the subscript means which term in the sequence we're talking about. It's a useful skill to be able to turn that into a sentence in your head. So when I see this, I think it's adding together the previous one and the one before that. N minus 1, I've seen a few times, it means the term before in the sequence. Later down here, this says something like f of odd number. The odd term is something to do with the sum of the squares of the nth term and the one before. So trying to turn it into words. I don't know if that helps me. Sort of squishy human brain understands the tricky abstract math concepts, but here we are. Right. Are the longer questions the same across everyone's test or depend on the course? Yes, that's on the MAT page. Everyone's doing the same questions this year. On screen, we have a question from 2023 where that was not the case and different people did different questions, but in 2024, everyone's doing the same questions to make things more straightforward. But yes, okay. Right, here we are. 1 plus 1 is 2. What are we doing? I said I would go faster, so I need to add faster, I think. Yes, it's about how many additions you do to calculate Fn if you do this repeatedly. So it's sort of about n or something, isn't it? And then maybe the first thing I would write down is like about n of them, because, well, every time I do an addition, I'm only getting one more term. I have to do an addition to get to F3, and then another one to get to F4, and another one to get to F5. It kind of feels like it's about the same amount of work, isn't it? And then if I really think I had to do one addition to get to F3, I have to do 2 additions to get to F4, I have to get 3 additions to get to F5, going up one by one. So I think that rule is that I need n minus 2 additions. Sorry, there's a building site next door and a crane is doing something interesting. Easily distracted. Right, what are we doing? Right, so next part of the question. Some questions are like this, where they have instructions for what to do, for which you get marks, and then some reading, for which you don't get any marks for just doing the reading. But you have to do the reading to understand what's going on. Here we are. Yeah, somebody in chat has posted Binet's formula for the Fibonacci numbers, which is, I think, why this question says, by the way, people like this, oh, they're not on screen, people who know Binet's formula will be asking me questions, I suppose, like, I only have to do one addition, but look, the question says, using the equation star, it tells you what you have to do, it tells you how to approach this. I think the people who write, yeah, you have to follow the instructions in the question, right? So not if you know some deep secret Binet's formula or something about Fibonacci numbers, then how many additions does it need? The question says very clearly using the equation repeatedly. There you go. Right. Not in the personal stucky. N stucky, come on. You can do an optional essay in 3rd year. I don't know what you mean. It doesn't contain this kind of creative writing like the personal statement. And now I'm going to get in trouble for describing personal statements as creative writing. It is a bit though, isn't it? Discuss. Are personal statements creative writing? Does the maths degree contain creative writing? Is mathematics creative writing? There are three discussion points for chat to think about while I struggle with the Fibonacci numbers. Is that what we're doing? That really is what we're doing, isn't it? Yesterday says, is the MAT 2024 paper the same for computer science and maths and computer sciences? Earlier they used to be separate questions. Yeah, once again, for 2024, all questions are for all applicants. Do all the questions. That is explained on the front of the test, and it's explained on the MAT website, and please do look at that. If that's a surprise to you, please do look at the instructions on, well, I guess the parent page of that one. We are currently a kind of child page of the overall department MAT page. Please do read about the format of the test. Okay, yes, people are now discussing this. Okay. Right, we're considering sequences of zeros of ones length n that don't have two consecutive ones. So for n equals 5, that's valid. I like this one better. But 0, 1, 1, 0, 0 is not valid. Sn being the number of valid sequences of length n. Ugh. So that's obviously hard. And sometimes when you're doing the reading bit of the question, you have an idea about what the question is going to be, but the natural question to ask here would be find Sn, which is hard. But luckily for us, math questions often have structure to build up ideas. So for example, here we start by working out S1 and S2. So if there's only one, if n is 1, then I have to list sequences that have only got n is 1 length. There's somebody in chat with username Len, which I think is short for length. So I guess it could be short for Leonard. But if the length of the sequence is 1, then there's only space for one number in, and there's only two numbers I'm allowed to use. So there are two of these things. And for n is 2, I can have this one, I can have this one, I can have this one, but I cannot have this one. I'm writing it to make sure I'm thinking about all 4 possibilities, but I'm crossing it out because I've remembered that it's not allowed. It's got 2 1s in a row. Okay, so we've got 2 and 3. Right. Then we're going to do a hard part, part 4, to show that it satisfies the same equation. Equation star way up there somewhere was an equation about adding together the previous 2 cases. And this is a reasoning part of the question, isn't it? Ah, I told you. Put them on screen. Come on. Let's give them the thing. Right, there you go. There you go, Martha. You came back in chat. Martha was here last year. If Martha's got any advice, I'm sure they'll put it in chat. Martha was here last year in your place and is now at Oxford doing their analysis homework. Go and do your homework, Martha. Right. Which doesn't involve writing. Maybe it does. Okay. So for n greater than or equal to 3, we're going to think about the first element of the sequence. Okay, so what am I going to write? I'm going to write silly things like first element is either, because we've seen questions like this before, I think, where you're supposed to consider 2 cases. I want 2 cases because equation star has got a sum of two things in, and if I could write this as 2 different cases, then I might get 2 different terms. When we've seen things like this before, there's usually a plus sign in the middle because somebody's considering different cases of things that might happen. Let's quickly look at a past question. That was quite a vague thing for me to say. Let me quickly point us an example. I'm now going to go and find an example. Let's go. That's not one. That's not one. Is that sort of one? No, that's not one. That is not what I mean. I'm going to look over here and then I'm going to give up. This one isn't printed in the question, is it? But there is a recurrence relation in that one. I have now given up. Back to where I was. Tail between my legs. I'm going to go back to the question I was looking at. Yeah, there's sometimes a plus sign in the middle, right? And this is one with a plus sign in the middle. E to the iPi, yes, there's a process to ask for more whiteboard paper stuff. Hopefully this is explained to you at some point when you arrive at the test centre and give you some material and explain how you can ask for more. I think you asked to swap it, so they take yours away and give you more stuff. Hopefully they explain this to you in the test centre. People who have done the TMUA can maybe chip in with how it worked in the TMUA, but well, yeah, somebody wants to know the pass mark for that. We don't really have a pass mark. Okay. Right, what am I doing? The first element is either 0 or 1. I suppose if it's 0, then continue with, I suppose I'm missing out a verb here, right? Then we can, sorry for the handwriting, I'm talking out loud as well though. If it's 0, then we can continue with a valid sequence of length n-1. I'm thinking about how to continue after this first element. They told me to consider the first element. I've decided it's either 0 or 1. Then we can conclude something, right? Not enough space. I've double checked, so having asked about Timur, you raise your hand for an extra booklet. I've double checked that people are getting given quite a lot of booklet for Matt. I don't know what the instruction was for Timur, but for Matt, we're asking for you to get quite a lot of booklet. The whiteboards are, right, well, okay. Right, anyway, if it's 1, then we can say something, can't we? We can say the next number is not 1, that is the thing that is banned. No, you can't have 2 consecutive ones. But then we can do anything, I think. I'm mostly saying this because I want to write Sn-2, right? I want to say, well, no, you've got n-2. And I think this is true as well, which is a nice bonus. Then we can continue with a valid sequence. And just to think, this valid sequence could start with anything, because this not 1 bit is 0 of length. So this, finishing my sentence over here, I am trying to think about 2 sentences at the same time, which is pretty bad. And I just interrupted myself with a 3rd, and now this interruption is a 4th. But to close the bracket on that one and the previous one, and get back to the 2 sentences I'm writing on the screen, we've got this idea that if it starts with a 1, then the next thing must be 0, and then you do something of length n-2, and I don't care what you start with because anything's allowed again now. And there's loads of those. There's Sn-2 for how many of them there are. So we have overall Sn-1 for these ones that start with a 0, and we have Sn-2 for totally separate, the ones that start with 1, 0, and then have some more stuff afterwards. Can we use binary, says someone in chat. Don't see why not. Does it help? I don't see how you can use binary, but go on. Yeah, the people marking it know what binary is, so go for it. The practice test was mostly to show you the format of what 25 plus 2 looks like. Okay. Okay, good. People are also telling me about pens and TMUA, which is good. Okay, right. We have got. Oh, I've got to conclude that Sn is Fn plus 2. Fair enough. They do the same. They do the same adding rule. These ones are coincidentally the same as those ones. So after that, it's going to be the same. That's an example of a place where I reckon I could string together a sentence. I'm not going to do it now, but I reckon I could string together a sentence, and so could you, to say, you know, if you've got 2 elements of a sequence that are the same between the F's and the S's, and then after that you're running the same rule which says to add together the previous 2 terms each time, then you will continue to have the same answers. 2 plus 3 is 5 for the F's, and 2 plus 3 is also 5s if we go and work out some values of S. And you could probably find a way to make that into a sentence. Good. Martha, who is pointedly not doing their analysis homework now, I think, says the MAT isn't the be-all and end-all. We do consider other factors. Martha is correct. Right, okay, good. But obviously try your best, is the follow-up from Martha. Good stuff. Okay. Right, so this has given us the impression that the sequences do the same thing as those Fibonacci numbers from the start of the question. They tell us to shift focus now, so instead of thinking about the first element, we're going to look at the middle element. But it's the same kind of reasoning. And the middle element, and again, there's me turning this into words, look, that 2n-3, n-1, that's about half, and actually then I go and think about it more carefully and decide that it is the middle one. The middle is either a 0 or it's a 1. If it's 1, then it's got to be protected by these zeros on each side, because you can't have 2 1s in a row. And there's got 2 possibilities here. This time, within each of those cases, you've got separate choices to make. And we've talked about this quite a bit in different contexts, right? That if you have mutually exclusive cases, you add those together to get the total number of cases. But if you have independent choices to make, so I've got a large collection of shirts and a large collection of jumpers, that gives me quite a huge number of choices about what I'm wearing, because I can multiply the number of shirts I've got by the number of jumpers I've got. And that gives me loads of possibilities. I'm supposed to multiply in cases like that where I choose independently. Separately, there are also some kind of parallel, some sort of separate decisions where maybe I wear some sort of fancy dress costume that doesn't involve a shirt and jumper. And the fancy dress costume possibly comes like a series of independent, mutually exclusive things that I should add up. They don't go together, they're just separate possibilities. There's me trying to justify why equations like this quite often have a bit of multiplication for independent choices and a bit of addition for mutually exclusive cases. Here we've got squaring, which is multiplying, bear with me, and addition in between. Also, it's a total lie. I've got an extremely limited palette of very similar jumpers and shirts. Good. Sophie wants to talk to Martha. I do have a current student as well. I feel slightly sorry for Callie, Callie is a current student who's been in chat every week of the MAT Livestream, answering people's questions about being a current student. I feel a little bit sorry for Callie, but hey. Good. Howard wants to know about the additional MAT, which was an additional thing we did last year. Last year we had terrible technical issues, which meant we had to run another test. Let's hope that doesn't happen this year. Right, okay. Good, okay. Look down here, you can see some addition and some multiplication. Maybe something similar is going to happen. Or possibly we're going to use maybe something similar is going to happen. Okay. So n greater than or equal to 2. Well, I want to do something similar, right? This looks quite similar. I mean, it has an fn squared in it, and it has something similar-ish going on with 2n's and n's on the right-hand side, and it has the same sort of pattern of multiplication and addition. So I want to think about this case. F2n means an even length sequence. So even length things don't have. Okay, I've succeeded in getting a shout out for Callie in the chat. Even length sequences don't have a middle element, they have a middle pair of elements. That is a fact about even length things, odd number of things, you've got a middle one. Even length sequences, you don't have a middle one, but you could have a middle pair. Where here there are kind of 3 cases, right? The middle could be 0, 0, or it could be 1, 0, or it could be 0, 1. If again we're looking at the middle, we've had to adapt the idea a little bit because there isn't a middle element. We can't focus on just the n-1th element. I don't know, maybe we could. Don't really know how it would work though. We would get asymmetric stuff going on and it wouldn't be this equation, I think. Maybe it would. Oh, I've confused myself now. Ah, yeah, because there's a 0 here, isn't there? Next to this 1, I can write some zeros. We get some consequences. I have to learn the lesson of over here, if you write a 1 in the middle, you get consequences. You have to protect it with some zeros on each side. The lesson down here is that if I think about these middle elements, middle pair of elements, I still get some consequences. And that gives me some weird asymmetric stuff, which I sort of like. And by the way, this thing on the right-hand side, I can write it like this. I'm doing this in such a silly way, but never mind. It's kind of the sum of 3 terms. So it's kind of 3 mutually exclusive cases, each one involving some independent choices with multiplication in there. Yeah, ooh, it does look a bit like a square, doesn't it? It's not quite because, oh, you're close though. You're close. Yeah, so let's get down to why did you square it in part 5? Why do you do squaring? And the reason for that is that you have this choice about what to put on the left. and you have a choice about what to put on the right. And you can make those choices independently. So we've decided Fn things that you could write in this gap of length n, and there are also Fn things you could write in the gap of length n on the right. So like my shirts and jumpers, if I've got lots of shirts and lots of jumpers, I get to write down a huge squared kind of quantity over here to measure just how many blue outfits I can put together. I don't think people are harsh enough in chat, but yeah, okay. Really good question in chat has just come through. It says, can we do this by bin A's formula? To which the answer is, I'm afraid, simply no, because it tells you by considering valid sequences, which I guess is disappointing if you know bin A's formula. Maybe you're very keen to apply theorem, walk away, but I think what I want to encourage you is that if you ever feel that some high-powered theorem just kills a question, then I think I'd encourage you to still do the question anyway, using the stuff in the question, because you don't want to miss out on the opportunity to demonstrate your problem-solving skills, to demonstrate your understanding of what's going on. Now, maybe that understanding comes from somebody called bin A, who has a formula or something, but you can demonstrate that by doing the question well, using the stuff in the question. In part 6, yeah, so we're getting part 6, yeah. Okay, let's get back to part 6. How would I show that working? How would I show that working? I think I would explain the link here. So I've got this on screen, I've color-coded them, which is silly of me, but you know. I think I would explain the link between the choices that I'm making. That here I would be keen to explain that I have mutually exclusive choices about middle element. Cases for middle element. They're calling it the m-1th position, but whatever. Middle element. And then I have independent choices for the leftover gaps to fill in. And exactly the same structure down here, just 3 cases instead of 2. So I think I can get 3 marks by explaining each one or something. Good, okay. Finally, part 7 is the kind of rider at the end of the question, added onto the question, I suppose, using the information that we've got so far, using the equations O and E, how many arithmetic operations do you need to calculate f2 to the k? Which I suppose means something like f2 to the k, just to write that larger or something. So my guess is something like this one lets you double the value of n, so I should look at this one, but awkward. It tells me this thing, but it also uses the value of 2 to the k minus 1, some odd number in here. That's a bit awkward, isn't it? So maybe for that odd number, I see. So to calculate this one for the previous thing, maybe I also need to keep track of these ones. Goodness me. Maybe I need to keep track of this one as well. It's using, that's an odd number, so I should look at this formula as well. I see why they're telling me to look at O and E, because the equations are going to relate together odd and even values. If I think about calculating both of these together, then I can take power of 2 and 1 less than the power of 2 and do however many additions and multiplications this is to get up to, I suppose, the next power of 2 and 1 less than the next power of 2 without using any other subscripts. So I can write down statements like 8 squared plus f7 squared, and f16 is f8 squared plus 2 f8 f7, writing in when n is 8, I think, yeah, 16, 15. You can calculate f15 and f16 from f7 and f8 without working out the ones in between, which is probably better than the thing at the top of the question. That might be the point of the question. Right. Good luck, Martha, with your analysis. Good luck, everyone else. Yeah, use part O. What's part O? Equation O. Yeah. Somebody wants me to use that equation. 2 sequences of length n and a middle element. Wouldn't the total length be 2n plus 1 instead of 2n minus 1? Oh, yeah, these n minus 1s. What is going on? Oh, I'm out by 2, yeah. I'm out by 2 everywhere. Yeah, okay. Do you know what it is? It's this bit. I think I've still been a little bit useful, but I've missed this. SN is, oh, goodness me. The number of sequences is not literally FN, it's FN plus 2. So I'm out by 2. Are these actually n minus 2 for the length of the sequence? Yeah, I think they are. Bother. Right, correction incoming. There's an n minus 2 here and here. And then you add 2 back on. Oh, goodness. Okay, there's loads of plus 2s and minus 2s flying around because the relationship is slightly more subtle. I know we talked about this part, but then I kind of forgot it and acted as if SN and FN were the same thing. They're not quite the same thing. Okay, right. Anyone else? Someone just says, I am so stressed in all capitals, and I feel that. Don't worry, it will get better. Are all interviews online? Yeah, all Oxford interviews are online this year. All colleges at Oxford are doing the same thing as each other. They're all doing online interviews this year in 2024. Yeah, so these equations, okay. Anna in chat says the equations have accounted for the change of 2. Yeah, the equations are right, I'm wrong. My little doodles are occasionally a little bit wrong. Morally, I think I get most of the marks. I'm out by 2 in a couple of places. Yeah, I think I can still get partial credit for explaining my cases carefully. To be honest, if I explain my cases carefully, I might not even. Whoa. Am I going to say it? Do I think both marks are for explaining the cases carefully? And might be one of the marks might be for getting me out by 2. Anyway. I usually stress about ID. Please talk to the test centre about ID. There is very little that I can do about ID. Please talk to the test centre. Please talk to Pearson View. There is, I think, if you've registered for the test, I think you have some way of contacting help or customer support. I think they're calling it customer support in the Oxford admissions testing portal where you booked your test. I think there's customer support in there. Which might let you talk to a different person at Pearson if you're not getting anywhere with the current person you're talking to at Pearson. Does choosing an open application make a difference? It's a good question because at this stage I can say not anymore. If you made an open application, you have now been allocated to a college, so you now have a college like everyone else. And the tutors at that college don't know that you made an open application. I mean, waiting for your MAT score, of course, but they don't know which of their candidates made an open application and which of them put their college down on the form, and also they don't care. Cool. Yes, okay, 2n minus 3, so you can ignore the 2 since it's asking for the n plus more than 1 term, not n minus 3. Yeah, there's a bit of that going on. There's a bit of that. There's a conversion from this n minus 1th position is why it's n minus 2. But then the reason it's Fn is that you get to add 2 to the subscript of the F. And the reason this one is F2n minus 1 is that you add 2 to this as well, overall. Complicated. Ruby wants to know if tutors started looking at applications. Not yet. I wasn't really joking when I said waiting for MAT scores. That we don't deselect anyone until we've got MAT scores in the system. Because we want to see how you solve maths problems. Oh, excuse me. Why are the equations why are the equations labelled O and E instead of A and B or star 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 star? I believe that those are the first letters of odd and even because we're looking at odd cases and even cases. Oh, I'm underneath chat. This is why you get switched off the screen. O and E are the first letters of odd and even for the odd cases and the even cases. I think that's what's going on there. I think you need to spot that. Right, I feel sorry for question 4, so I'm going to talk about question 4. What is it? It's 5 to 6. Did talk about that question for half an hour. Let's try and do question 4 really quickly. I always regret saying this, but I think this question is based on an idea that I had for a question. I always regret saying that because now I'm the adversary, right? Usually when I'm talking on the stream, I say things like, question setter has done this thing, they want us to do this. if I admit that I think this was my idea, then I become the bad guy. I mean, maybe you already thought that anyway. What's considered a good math score? Someone says in chat. I always say about 70. I think you should be proud of a math score of about 70 because the test is hard. We don't have a hard pass-fail mark, so I'm not saying that as a 71 you go to Oxford, 69 is fail. It doesn't work like that. We look at everyone's math scores in kind of the context, and some years scores are higher or lower than others. That's something to do with setting a different paper every year, and something to do with getting a different pool of applicants every year. You usually mess. This is absolutely on blast. Look at this. You usually mess up questions after saying this is my idea. They posted it twice as well, and they're getting thumbs ups on both. Absolutely straight to my heart. Right, this is my idea. I'm the bad guy, and now I'm going to get it wrong. Let's go. There's a parabola, y is 1/2 x squared, and there's a point on this. Maybe anonymous chat was a mistake. I really love the live stream. I'm sorry, I try not to be too soppy, but I really love the live stream as a way of current applicants being able to get in touch with us about their applications anonymously and get some help with a maths test that we're also going to use to decide which of them we're interviewing. Great stuff. Point A, 1/2 a squared, is some point on the parabola. There's a line L, and B lies on L such that distance AB is fixed positive number D. Ooh, normal to the parabola, there we go. Normal to the parabola. This distance is D, well, it's quite a lot to label, isn't there? This is called B. AB is fixed and it's above and to the left because A is positive, so we're over here on the right somewhere. Good. Okay. Find the coordinates of B in terms of A and D. Straightforward coordinate geometry sort of stuff. We know where stuff is, we know how normals work, we know how tangents work. In this question, we're going to get 6 marks for doing this. That is exactly the sort of thing that I want to be doing. I can write down the, so the gradient of the tangent is 2a, so I want -1/2a for the gradient of the normal. And I want that to have gradient -1/2a, and I want it to go through a and have value 1/2 a squared at that point. 2 things that I'm doing there. One is remembering facts about normals and tangents while differentiating a quadratic quickly. Oh, I'm wrong, I've missed a factor of 2 because the parabola is 1/2 x squared. Don't tell me in chat, don't tell me in chat, I'm not looking at chat, I'm not looking. 2x, so a, the gradient is actually just a, isn't it? Plus 1/2 a squared. I think I'm good. Okay. 3 people in chat all at once. Oh my goodness, I'm so the adversary in this. Right, let's go. Okay, that looks all right. There's an equation, I think. It was never there. -1/x plus 1 plus 1/2 a squared. Oh, now I've got to look at the minus signs really carefully. Chat's going to come at me. Good, right, okay. Goodness me. Right, that's the normal, and I want a point on that line that is a distance away from A, distance D. 2 ways we could do this. We could do some sort of Pythagoras thing to think about the distance being the sum of this thing and that thing. Don't hate that idea actually. We've got some sort of change in x. We know the gradient now, so we could do some sort of this thing being maybe -m times that x distance. Sum of the squares is D. Yeah, don't hate that. Don't hate that. I think that's all right. Or we could just brute force write down the distance between this point and A, and set it equal to D. Do some squaring, do some rearranging. What do we want? Do we just want the x coordinate? We want the coordinates of B in terms of A and D. I think I'm going to write down the distance. So for this general point, x, y or something, we've got, so if I bend notation a little bit to write down x, x and y for the coordinates of B, if I imagine b is at xy, that says that, so we've got to put a big space in between b and at. I was bending notation a little bit because I'm already using x and y for my line, but I think that's all right because b lies on the line as an example of x and y that satisfy that equation. We should have, yeah, a is non-zero. Don't get me that easily. I'm dividing by a. Chat knows not to swear or divide by 0, so they're on me for this. Okay, so that's the change in x values. I've also got this change in y values to think about, which I believe is this squared, of course. Half a squared, because that's the y coordinate of a, and then b is up here somewhere, that's the y coordinate of b. So yeah, okay, I should take the difference, square it, and that's supposed to be d. So this is d squared. Don't love this equation I've got myself into here. Oh, it's not too bad. It's not too bad at all, because these brackets are extremely similar to each other. Yeah, okay. Maybe you've already noticed this in chat, but I can do some kind of operations over here to bring out a factor of 1 over a squared. Maybe chat's already spotted this. The brackets both kind of involve an x minus a squared. So I can do something like that, and then write down that x minus a squared is b squared over 1 plus 1 over a squared. And now we're off to the races, aren't we? Take some sort of square root. I don't know if this is a plus or minus sort of situation, but I think everything's positive, so I'm going to go for it. And then I know y from plugging back into this equation over here. I should maybe have moved this all over a at the top. Good. How did I get that second bracket? I did some magic, didn't I? Where did the 1 minus x over a squared come from? So I have this y coordinate for b. Maybe I should be more precise. I'm going to call yb. I'm going to give them names. This is slightly better. So I know over here that it's supposed to be yb minus a half a squared because that's the y coordinate of b minus the y coordinate of a, and I know the y coordinate of a, it's on the parabola, and I'm squaring because that's how distances work, Pythagoras. Yb, I've got an equation for it, which I've also rearranged a tiny bit to move the 1 to the front, and the half a squared appears in both, so that's quite nice. Okay. Is it related to a circle? Quite possibly. There's a square, there's a tangent, there's a right angle going on. Who knows? Doesn't feel impossible, does it? Oh, I've got too many A's in here. Right, Anna wants to think about it in terms of vectors, where B is the point on the line plus D times unit minus A1. Yeah, that's pretty good. That's pretty good, I like that. Gives a slightly different answer to mine, doesn't it? Which makes me nervous. Oh no, we're good, we're good, we're good. We're good, I think. Plus, I know I'm saying plus minus. Do I think x is larger than this or smaller? We were told it's to the left. To the left, so I suppose I want x. Yeah, I've started to think that this was not a good method for this question, but I have got down to an answer. So I'm sort of happy. Similar triangles in chat. Pretty interesting suggestion. You know the gradients of everything, so you can write down, I think, sort of which way around is it going to be. You know, kind of this angle and this angle are the same by 90-degree things being perpendicular to each other, so you've got some similar triangles going on. Anna's vector suggestion is currently looking like the thing that I would be most likely to write down. A minus AB over root a squared plus 1. If I multiply up this 1 over a squared in the denominator is annoying me. If I multiply someone by top and bottom by a, I get AD upstairs. I can bring the a that I've put downstairs inside the square root to give a squared plus 1 inside. Yeah, I've simplified, okay, which I've done partly because Anna says they've got something different. Okay, I think I'm now on track, aren't I? What have I done? That's my x coordinate. And then for the y coordinate, I suppose I should go and plug this in over here, and it will do the following. It will subtract the a, multiply by minus sign to get rid of this, divide by a to get rid of the a upstairs, and then add half a squared. That's the xb coordinate. Put my subscripts in everywhere. and yb, so I think I want 1/2 a squared plus d over root a squared plus 1, which is looking a lot more like the thing that I would have done. Oh, underneath the bottom bar. Looking a lot more like the thing that I would have got if I'd done some sort of vector-based thing. Yes. Okay. Cool. I've got some coordinates. Ooh, Anonymous has made a Desmos thing. Anna's also Desmosed it. 2 people have Desmosed this simultaneously. Isn't that nice? Have they made the same Desmos thing? Let's find out. We're gonna put both Desmos things on screen. It's not a competition. It's a 6 PM sort of break. If you've seen the stream before, we like to take a sort of quick break at 6 o'clock. Here's one Desmos thing. Oh, I can move this one left and right. Right angle stuff. There's the point. There's the point over there. Looks like a fixed distance. Looks very convincing. They've got lots of square root d squared. I think d's positive. You can bring that out. Okay, other one. I've forgotten which way around this is. They've got, oh, phantom sort of. They're not showing me the lines, just the equations of these points. Where things end up looks pretty convincing. Looks like a straight line of fixed distance to me. And they've brought out d out of here. They've plotted the same things. It's me. Right, good. 6 o'clock. If you've been looking at a screen for the last hour, then maybe look away from the screen briefly. I'm going to drink some water, trying not to somehow weirdly splash my own glasses at the same time. Great success. I like to keep you updated. If you've tried this question already, then you're in for a ride while we do the rest of it. If you haven't tried yet, then maybe this is your chance to get ahead. That's a joke. I'm going quite. I think I'm going quite slowly by being quite bad at algebra. Cool. What's going on? What's going on? How many hours should one study? That is a very hard question. We advise our undergraduates that they should have roughly the same number of hours as they would if they had a 9-to-5 job. So we think it adds up to about 40 hours when they're undergraduates, but it's really hard to count when you're an undergraduate because, well, I had some of my best ideas while I was not sitting at a desk, so I don't know if I'm supposed to count those hours or not. With the new system, will there be questions? Here's John's question. With the new system, will there be questions based on things that were previously only for certain applicants? No, because there are no such things. There was a single syllabus for all applicants, and that's still the case. Right, so maybe you're looking at this and thinking, well, previously, computer science candidates didn't have to do geometry. That's actually not true, because computer science candidates had to do question 1, which included all sorts of stuff like this. Yes. I get inspiration when I am swimming. There you go. Right, okay. Anonymous and Anna still on the same page, I think. Assuming it's the same Anonymous, which I usually do. Right, good. Nice break. Like it. Was it me trying to get out of doing the rest of this question? A tiny bit. Let's go. We've got an XB coordinate. We've got a YB coordinate after my algebra, which I've got very narrow, haven't I? Very narrow with my algebra. We've been asked about this lying on the parabola, which means we should say something like is yb equal to 1/2 xb squared. You see, I remembered the 1/2 this time. So is 1/2 a squared. I'm copying out the coordinates down there. Is this thing equal to 1/2 of a minus a root a squared plus 1 squared? And the good news is that when I multiply out this squared, I'll get a squared over 2, which is going to cancel on both sides. That gives me enough hope that this is, along the right lines. Why have I written a plus sign? What am I hoping will come next? It's going to be the kind of cross term next, isn't it? Where I get 2 cancels with a half. I'm being a bit slapdash. Maybe this is a bad idea. Maybe I should square more slowly. No. What's the worst that could happen? Right, okay. This is cancelled on both sides. This appears on both sides, to be precise, and now it's going to cancel because I'm going to cross it out on both sides. And what am I left with? Oh, brilliantly, I get a squared here that I can move over to the left. how many of these terms do I have? 1 on the left, and after I've moved this one over, a squared more of them, which I have strong feelings about, because that's going to go there. I've still got this thing on the right. I think this is going to work out, isn't it? There's loads of factors of a squared plus 1. Possibly 1.5 of them when the dust settles, which is the number of them that I want over here. With the 2 over there, a squared d because the factor of d on both sides. All good. I think that'll cancel down nicely. What is a question like this testing apart from algebra skills? It's a good question, isn't it? I think it is. So there is an algebra slog element to this, that people doing this question had to do quite a lot of algebra. There is, for the first part there, some decision about how you're going to find the coordinates of B. I think I chose maybe an okay method. Other people in chat had other ideas. There's a problem-solving element a tiny bit there about how you're going to find out where B is under these slightly weird conditions that B is above and to the left, and that A is positive, and there's some description of the parabola. Some slightly weird conditions where maybe some choices to make about how you find B. And there's a switch here to know that lying on the parabola means the equation. I've done that straight away by switching to the equation for the parabola, and then I've got to do some algebra. Later on, I think there's a little bit about talking about minimum values of powers of functions, which there's a slight subtlety to this argument later on, but you're right, there's a lot of algebra in this question. Did I answer Ivy's question? Whoops. What was Ivy's question? Will we know how many marks the question is worth? Yes. The questions say how many marks they're worth. The separate parts in the long questions say how many marks they're worth. And the multiple choice questions say how many marks they're worth. Sorry, I was staring into the abyss, really spoke to me. Abyss. Good word. No, bad word, I suppose, in this context. Yeah, won't be a question like this year as a long question, because we would have to type lots and lots of algebra. I think that's a fair enough thing to say, isn't it? But you're not expected to type complex maths expressions. These ones are getting pretty complex. How are the long questions marked? I've got a team of grad students who mark the long questions, and yes, you get marks for partially correct solutions. Partial credits. We've hit 255 chat messages, so I think it now rolls over back to 0 again if anybody says anything else. When we hit the nice round number of 256. Obviously, I can't comment on whether any of the Halloween questions are themed Halloween questions. Sorry, if any of the maths questions are themed Halloween. It's on Halloween. Drink water. Think about what you're doing. We've got a parabola question going on. There you go. Thank you. I'm really glad that lined up nicely. Good. Right, chat's going away because it's hiding all of my beautiful algebra over on the right. Algebra I do not want to type up. Right. Okay. Let t equals a be equal to a squared. So t squared. No, wait, not t squared. T times d is 1 plus t. I can't spell the letter t. In the form d to the 2/3, so I should sort of divide this. So maybe there's an idea here. Oh, there's a power of 2/3 going on. Divided by t to the 2/3. If I do a kind of power of 2/3 everywhere, my function of t is something 2 to the 2/3, 1 plus t, divided by t to the 2/3, which is a bit weird. Find the minimum value of f of t looks harder than it actually is, because this is two things together, isn't it? T to the minus 2/3 plus t to the 1/3 in disguise. There's two separate terms, and I can differentiate that term by term, and then I'll use that value of t, the minimum value of f of t. Yeah, so there's a really subtle bit going on at the end, right? To say you've done all of this algebra to talk about where b is, whether it lies on the parabola, whether that thing ever happens. So it's a complicated question about, is there a value of t? Is there a value of t for which this inequality is true, given the value of a, or something like that? Nope, yep, I've said all of that wrong. Is there a value of t for which the equality holds given a fixed value of d? And then if you change d to a different number, you can get different answers. So some minimum value of f of t, and then one way around or the other, that tells me whether or not there are any solutions. Because let's think, if the minimum value of f of t is larger than your value of d to the 2/3, then you never get any solutions to this, because f of t never goes low enough to get down to d to the 2/3. That's the kind of critical way around. You get you will not be able to find some value of t, or equivalently some value of a, such that f is small enough to match up with d to the 2/3. Good. Okay. Right. Okay. I've done that bit out loud, I think, rather than differentiating this. Is that the coward's way out, to not differentiate it and just talk about it? Yes, it is. I think that's the idea here, that f of t is some quite complicated function, like this maybe, 2/3, t to the 1/3, some sort of complicated function, but it has some minimum value. We would like it to be equal to d to the 2/3, which might be too small. So if d is too small, then you never get any of these. If d to the 2/3 is a bit larger, then it's not too small. You do get some values here. Some values of t, which means some values of a squared, such that the point B does lie on the parabola. Good. So in those Desmos demos I was sent over, for some values of d, this doesn't happen. The equality is never true. The point B never lies on the parabola. But for some values of d, the point sometimes does lie on the parabola. What a complicated thing. What's with the 2/3? Yeah, so my 2/3 thing is because I really wanted to get some function of t on this side. I think I wanted d to the 2/3. Why do I want d to the 2/3? Ah, right. Here's what's with the 2/3. So let's rewrite what we've got. At some point during the question, the kind of natural thing to do is to rearrange for this, to get some expression like this, relating together the d, the length of AB in the question, and t, which is something to do with a squared in the question. And this is a condition for B to lie on the parabola. So the natural thing to do would be to find the minimum of this function. The minimum of this function, and talk about whether d lies below the minimum of this function or not. The problem is that using MAT methods, differentiating combinations of powers of t, you can't differentiate this using MAT methods. You can differentiate this if I raise everything to the power of 2/3, because then it's the sum of two things that you can differentiate. But with the power of 3/2 on there, you can't differentiate this using MAT methods. So the 2/3 there is to make it into a MAT question. Oh my goodness, right, okay. Can we use AMGM and use the equality condition? Yeah, sure, it asks you for the minimum value of f of t, right? So if you want to use AMGM for that, go for it. Use whatever method you like, because it just tells you to find it. It doesn't tell you to use differentiation. So if you want to use some other method of finding the minimum value of a function, go for it. Okay, what a lot of work. There we go. Hydrogen. So I was listening to the start of the live stream and realised I haven't linked my UCAS ID to Matt. Any thoughts on what to do? Does that mean that if it's the case that when you log into the Oxford admissions testing portal where you booked a test slot, if it says warning, you haven't been matched to a UCAS ID, then you should contact contact customer support in there, and also contact the admissions office at the college you've applied to promptly, because we would like to match you so that we know which MAT paper is yours. If you've genuinely applied to Oxford, then just carry on, do the MAT. But if you haven't been matched, then at some point you're going to find out, because you will get contacted to say you don't seem to have applied to Oxford. What are you doing? What are you doing? What are you doing signing up for the Oxford test without applying to Oxford? Who are you? You'll get some sort of message like that. I suppose if you haven't got that message yet, then maybe everything's okay, but you can check. Right, good, okay. How will we get working marks in the actual test? I've been saying partial credit. You can get partial credit for things where you're not quite right, or it's not quite all there. For the long questions, you should expect to explain and justify things, like how in this question, what are we explaining and justifying? We're just doing stuff in this question, aren't we? And we've got to show that. Show that is a bit explainy, where you've got to explain something. So if there's a part of the question where you're trying to explain why something's true, if your explanation is not quite there, then you can get partial credit. I think someone earlier asked us about getting partial credit, so there you go. I have not applied to Oxford. I've booked MAT and Tamua. Your MAT booking is going to be cancelled. You will not take the MAT. The MAT's only for Oxford applicants. You want to do MAT for practice? That's not an option. The MAT is only for Oxford applicants. Sorry. Yeah. Right, okay. More light-hearted. Sophie wants to know. I type it every time. I don't know what Callie does. I type it every time. I've been typing arrow thing James to sign off messages for approximately 5 years, so I've got better at it. Right, there we go. Yeah, Callie also types it every time. Right, good. I should do a keyboard macro, shouldn't I? I should have some keyboard macro that signs my comments. Or even better, it should actually indicate some sort of authenticity. Right, good, okay. I'm pausing a little bit because we've hit the end of a question. I think I'm going to turn the vote back on, which is currently populated with stuff. Oh, kind of a little bit of me wants to reset it. If nothing else happens, we're going to do short questions 1G and 1J, but I am also going to reset it just to see how people are feeling right now. Wait, if you're voting, give me a second. How do I reset it? Okay, I can't be bothered. I know, I will go for it. I'm going to reset it. Okay. You can't reset while it's active. Okay, fine. Do your voting, but we're also going to be slightly held to people from the past. Also you, but we're going to be slightly held to that. Off you go. See what happens. Chat doing all right? Chat wants a reset. Right, hang on 2 seconds. Chat wants a reset. Reset. A do-over. I guess that's only a little. It's a little bit democracy. Look, different things are winning, and then the same things are going to win. Democracy is going to work. Okay. Right, what are we doing for time? It's 6:20. We can probably do a couple of short questions. Maybe talk about themes of long questions. Let's have a quick look at the other things. This question, if you're interested in this sort of stuff, it doesn't really require anything from the syllabus, which kind of means that anyone can have a go at it. We're not assuming you've seen anything from A level. Anyway, the way this question works is all about converting complicated trees into codes, and it's not the most obvious way of converting between the two, but the whole question, I think, rewards you for understanding what's going on in this process. You're presented with something complicated and asked to essentially understand it. Lots of maths degree is a bit like that, where there's something kind of maybe not the most obvious thing or the most straightforward thing. The way this code works is slightly complicated, but it's a good idea. It's a good thing. It's a genuine thing. Anyway, genuine thing. Computer science, maths, genuine things. So there are several parts of this question to try and get you to think about it in different ways or to build up your understanding. But ultimately, the way you succeed at a question like this is to understand what's going on, partly by considering what you were doing in previous parts. Thinking about 8 only has 8s in. It means a very particular thing in this question, you know, building stuff up. And I also want to quickly point at this question, which talks about maximum values, and there's lots of numbers in. Some of the numbers don't matter. So another example of a question where not all of the numbers actually matter, like here, without differentiating, write down the maximum value of cosine of some stuff. And the 30 degrees in there does not matter. And the 2 also sort of does not matter. Right, okay. Don't at me. I know if the 2 to switch to a 0, then it becomes a slightly different question with the same answer. Right, good. This question is about solving tricky equations. I like the way this part says find all real solutions to the equation, because by this point, if we just jump in at that point, impossible. If we've got some distance in, then maybe we can work out what's this got to do with functions like this. So x to the n plus x to the minus n are balanced between positive and negative powers. This equation, obviously nothing to do with those because it doesn't have any negative powers of x, unless it's not balanced between positive and negative powers. Could we introduce any negative powers? I guess we can multiply. Good. Right, quick look at the long questions, because I think the short questions of winning this poll is come back with pretty much the same ones before we reset this. So let's do G and J, letters that are hard to distinguish depending on your accent, and we'll see. That was like computer science trees, but I'll let you in on a little secret that computer science doesn't actually own the concept of a tree. You can't refer to trees as, oh, that's computer science. I will never understand what's going on with a tree. Unfortunately, they're just content that you can learn about, whether or not you're a computer science student. I've never been a computer science student, and I think I know what a tree is. How did that happen? I'm being so silly. Right, what are we doing? What are we doing? Yeah, okay. Unleash ultimate sarcasm. I don't know, I've got kind of very sarcastic. I think it was being told that I would fail at question 4. I think that's maybe choose to be like this. Right, how are we doing? We've got half an hour on the clock. We've got a quadratic equation on the board, 2 actually, and we're asked about a third. Right, what's going on? These equations have a repeated real root. It's nice to know, isn't it? So I think it's on a flashcard or something, but maybe when you hear about a quadratic equation, your ears prick up a little bit because you know about quadratic equations, and then you hear that it's got a repeated real root, and you think, you know about that sort of thing as well, right? You know that that's got something to do with the discriminant. I suppose the joke here is that you want to write down b squared minus 4ac, and this one also involves a, b, and c, but in a different order. So we've got these 2 facts. I'm going to copy them out here a little bit larger, just to make sure everyone can see them. This is sort of all that we've been told. This repeated real root fact tells us this stuff about discriminants, and if these discriminants are true, then you could rephrase that in terms of quadratic equations. Yes. Discriminant is 0. Yeah, here we go. We got 2 facts. What are we being asked about? Well, we're being asked about another quadratic, and I guess we're being asked, more importantly, how many distinct real roots is it? So I'm going to translate that. Translate what is, and then I'm going to write down the discriminants of this quadratic, focusing really hard. Oh my goodness. I'm going to almost write down it was 0 by just pattern recognition, right? 0, 0, obviously 0, right? The real numbers a, b, and c are non-zero. There's always these sort of terms and conditions at the top to tell me about the numbers. Not always, but sometimes that's where to find them. Okay, so I suppose these are equations, aren't they? They say b squared is equal to 4ac and c squared is equal to 4ab. I would like to know about bc relative to a squared or something. Can I make a bc somehow? Can I say something about bc or something about a squared? I've got an a here and I've got an a there. I'm sort of seeing different reasons to sort of Multiply? Do I want to multiply? Try some values. Yeah, you can try some values. You're going to have to invent values where these things coincidentally both have real repeated roots, which is tricky. I guess you could look at these equations and try saying, well, if A is 1 and C is 1, then B is 2, but that doesn't work over here. So it's tough. You got to try some numbers that work. It's not obvious how you're going to find these. Rearrange for A on both. Yeah, I like that. I like that. So for this to work out, good thing they're non-zero, by the way. I would like to do this sort of jumping around. Am I good so far? Have I divided correctly? Chat, let me know. No, I think I'm good. Yep, I think we're good. We've got factors of 4 all over the place. Looks like b cubed is equal to c cubed, and they're both non-zero, and cubing is good, isn't it? Yes, b is c. B is equal to c, chat. It's a good fact, isn't it? And then if b is equal to c, I can cancel one of them from each side. B is equal to 4a. So we've got a, 4a, I think. Which means we are left with this quantity up here, a squared minus 4cb, the mystery discriminant determinant. What are they called? I've said both now. The mystery thing that tells you how many roots a quadratic has got, I'm getting tired, is a squared minus, and then these things here, this c is secretly another 4a, and the b is another 4a, which is a lot of 4s, 1664, negative 63a squared. Interesting. How about b is minus c? Ah, they don't have the same cube. I paused to think for a long time. I should have kept talking rather than just going quiet, but with cubes, it's really one-to-one. Big pause there for me to think about whether that's true or not. They're not negative c. I looked up here to check if they were positive, but then I remembered that cubing doesn't work like that. Cubing doesn't have the same problem as squaring. Squaring, you have to think, oh gosh, plus or minus have the same value. Cubing's nice. Cubing's chill. It's a one-to-one function. I keep saying that and then panicking that it might not be true. Would it work to multiply to get a squared? Yeah. Okay, this is minus 63a squared, so sorry, punchline. A is non-zero, this is negative. So you might expect this to turn out to be 0 again, but it's actually negative, which means that this has got 2 real roots. Because the discriminant, no, wait, none. The discriminant is negative. It's got no real roots. Almost got me at the end. Discriminant, hooray. Would it work to multiply to get a squared in terms of b and c? Yes. I was about to do that until chat said to rearrange for a, so I did what chat said. I was looking at these two equations, I'll put a purple box around them. I was looking at these two equations, and the thing that I was thinking about doing was to multiply them to get b squared c squared is 16a squared bc. And I was trying to work out if that would give me, well, that does actually work, doesn't it? Because then I can divide by bc to get 16a squared. Maybe you tried this at home as well. And then I can put the b squared in there, bc. It keeps the b's and c's together. It's kind of nice. 16a squared, and then I get back down to minus 63a squared again over here, which isn't negative. Pause. Yes, because minus 63 is negative. Right. Sophie thinks that b equals c equals 64. I don't know about that. Because I think that, so I've got this quite a general thing down here where I think b and c are equal for sure, but value depends on a, and I don't know that a is 16. Maybe you've done some more work and decided that a is 16. I don't know. And now I want to go and think about the case a is 1, b is 4, c is 4. Then the first one becomes x squared plus 4x plus 4, which does have a repeated root because it is x plus 2 squared. And I also want to think about 4x squared plus 4x plus 1, which does have a repeated root because it's 2x plus 1 squared. Maybe I should be thinking about what the repeated root is, because, suspicious, negative 2, negative 1/2. Is it the case that the roots... Oh, I don't know. Right, okay. Add all the discriminants and factor out and we're done. Add them. Add them. I've never heard of adding them for this question. What does adding them give you? B squared plus C squared. I can see difference. Do you want to do the difference? Difference looks like fun because the difference gives you difference of two squares. Chat, did we just write another MAT question? What's the difference of the discriminants? It's 0, by the way. The difference of these involves b minus c. And also this b plus c plus 4a. This is how Sophie's got a 4a. No, wait. No, maybe not. So either b is equal to c, or b plus c is negative 4a. Oh, but that's not good. So b is equal to c. Okay. And I'm being inconsistent with that one, but maybe this is your clue that b might be equal to c, or something. Unless. That does look like it could be 0. What would that mean, though? Interesting. Another case, maybe. But not really. You can complete the square on... What is this? Chat's going off. Complete the square on a plus b plus c all squared. Oh, you want to add that one as well? You want to add that one? That's pretty good. And then it turns out to be something like a... Oh, gosh. What on earth do you get? Oh, complete the square, and everything's quite symmetric. So you're going to conclude this thing is negative. You've got a 0 term, and you've added a third thing and ended up with a negative total. I like that a lot. Enough that I'm going to write it out. If you add together all the things, the two things that we know are 0, and this last one, yes, good. Did you say a squared minus 4bc is b over 4? Oh yeah, that looks true. Anonymous at the top. I think I agree. Just being told you can do this by completing the square, which is a bit magic to me. Now I'm confused. Oh, I'm losing the magic. This was magic a second ago. Oh gosh, how does completing the square work? Is it like this? But then subtract loads of squares? I feel like I'm doing a lot of work now. This has started to feel like a UKMT question or something where you've got to do loads of things. So it's going to be 4a squared, but then I want a minus 3a squared, minus 3b squared, minus 3c squared. So sort of complete the square, but the other way round to how you normally complete the square to get this. I don't know what this is. Is this positive or negative? I don't know. I don't know at all. I don't know what I've done. Right, I'm going off this. I'm going off this. And yeah, suggestion, explain what I did when I'm finding the difference. I'm going off that as well. I've tried to factorize it and I'm not sure I did it right. And there is a suggestion that I switch and talk about 1j instead, which I'm going to take. 1j is a very complicated function. If x is between 0 and 2, then, oh my goodness, 3/4 to the power of brackets, which are defined over here, log base 2 of x. I think this is 1j for a reason. Someone in chat's got a distinction. Well done. Oh my goodness, someone in chat's completed the square. Oh, but don't. Oh, yeah, okay, for the quadratic. Yep, carry on. Can you take the derivative? Not normally, right? If someone gives you a quadratic equation for x, don't take the derivative of this. But for the previous one, if you have, if someone gives you a quadratic equation and you're interested in the roots, it's not really okay to differentiate that. You'll get a linear expression which tells you something about the gradient. I suppose that's 0 at the repeated root because you've got a turning point there, but you don't really know where the root is for that question. So I wouldn't go and look at trying to find the value of x in either case. 1g seems to me to be all about the kind of number of roots rather than the values of the roots, which sounds like splitting hairs, but maybe that's how I make progress with it. Yes, good, okay. This question looks hard. Here we go. Let's break it down. So, it's a combination of functions. There's a 3/4 here, which I'm not scared of because it's just 0.75. And it's been raised to a power where the power is just crazy. Log base 2 of x has been put into this function, or these kind of brackets, that take the largest whole number. So I want to think about log base 2 of x between 0 and 2. So between 0 and 2, log base 2 of x, let's do that first, would look like very negative over here. It goes through 0 when x is 1. Yeah, 0 when x is 1, and gets as high as, almost as high as 1 for log base 2 of x. So many extra functions apply to it that I've got to be really focused and just think about the one I'm currently talking about. Goes through 1 in the middle, almost gets to the value of 1 up here, but not quite, because x doesn't quite get to 2. And down here, well, it goes off to negative infinity very quickly. As you get close to the value of x equals 0. It doesn't do that one either, because that wouldn't be allowed. And then we're being asked about, and this is the thing that I've had in my head while I was drawing that, the largest whole number, which is less than or equal to x. So things get rounded down. So all of this stuff in here gets rounded down to 0, because it's somewhere between 0 and 1. And then there's some stuff in here which gets rounded down to -1. And the question, I suppose, is how much of it gets rounded down to -1? And we've seen questions a little bit like this before, where you have separate cases and things going on, involving, I think, logarithms, where the key is to think about what powers, what numbers you put in that give you whole number outputs. So these numbers feel relevant to me because they're the points where the rounding switches. When it hits the value, when it hits -2, well, any further left of that, things start getting rounded down to -3. So we've got this kind of set of rounding things down. Okay, what have I decided? Let's write it down. So I've decided that rounding this down is, in first case, 0 if x is between 1 and 2. I think it's -1 if x is between 1.5 and 1. I think it's -2 if you're between 1/4 and 1/2. I haven't decided. It's less than or equal to. I haven't decided which way around the equal signs go. Yeah. So there's some geometric series stuff going on, right? Because geometric series work together really nicely with logarithms, of course. I say of course, but all I mean by that is that log base anything of this is just by log rules. It's quite nice. You can expand it out. You get a first term and n times some sort of difference. If you take the logarithm of a geometric series, you get an arithmetic series, which seems nice. I think that's true. Yeah, good. Okay. Let me think about these a little bit more. So in between, x is not as small as 2 to the -3, not as large as 2 to the -2, it's 2 to the something in between. And something in between -3 and -2 will get rounded down to -3. Just like in here, well, somewhere in this interval is, and it's a bit weird to think about, is 2 to the -pi is somewhere in between 2 to the -4 and 2 to the -3. 2 to the -pi, when you put that in the logarithm, you'll get -pi, and then -pi gets rounded down to -4. So things are rounds down to the largest whole number that is less than x. Good. Phew. Right, okay. So this thing is counting its different counting numbers with a minus sign, depending on powers of 2 for the range of x. Okay, let's check our understanding. f1/2. Oh, that's exactly in here, is it? Is one of the examples where you get -1. Because if you put 1/2 in, you get -1 here. -1 gets rounded down to actually -1. The inequalities work like this. Not important, but I want it to be correct. There we go. It's rounded down, and then that power of -1 gives you 4/3. My goodness. Okay. So the value of this integral is, and then you've got some options, and the options are just 1, 2, 3, 4, 5, which is somehow terrifying. The things around x are not modulus. They've got little floor bits on the bottom. They're sort of halfway between mod signs and square brackets. And this is a definition at the top. Let this denote is a definition look. of the largest whole number that's less than or equal to x. For example, it's not saying that the modulus of minus pi is minus 4. That's not true at all. It's saying that this thing of minus pi is minus 4. Not quite modulus, kind of rounding down, I've decided, in words, because it returns a large whole number, so it's sort of like rounding if there are any decimals involved, returns a whole number that's less than x, so I'm thinking rounding down, and like the largest one that's less than or equal to x, don't round down to a random number, round down to the sort of next one down, or equal. Right, we've got to integrate something. What are we integrating? 3/4 to the that. So now I'm going to go and think about 3/4 to the that. And I'm going to do some cases, and then I'm going to draw a picture, I think. So different cases. If the function up here is 0, then I'll get 1, because anything to the 0 is 1, more or less. That's the case if I'm here. And then if this is minus 1, like in the example, I'll get 4/3. And then if it's minus 2 up here, I'll get 4/3 squared, which I'm going to take the lazy step of not multiplying out, but you know me, I would probably get it wrong anyway, and so on and so on and so on. So it's kind of these increasing powers of 4/3, because it's going to flip it with the minus sign. I noticed there's minus sign and then increasing powers 4/3. There's a geometric series again. So I've got, if you like, let's try and graph that. As you get closer to 0, you get rectangles that are half the width and, oh gosh, 4/3 as tall. So going left, you get this kind of series of rectangles. I'm going to add the areas, because integration means area under a curve, which is a lot, isn't it? 1 plus, and then the next one is 1/2 times 4/3. The next one is 1/2 squared times 4/3 squared, and so on. Each of these contributions is 2/3 the previous one. So I've got 1 plus 2/3 plus 2/3 squared plus, oh my goodness, 1/1 minus 2/3, which is 3 as a final answer underneath my camera. Okay. Goodness me, are you supposed to know the floor and ceiling functions? No. This one defines it, right? It tells you what it is. Questions can introduce new stuff. So you might say, am I supposed to know this weird property about the Fibonacci numbers? No. Question tells you all the information is in the task. Good. It is called the floor function. I think I've managed to not say floor. Sorry if I said floor at some point. Some people might have seen floor function. I think we've seen floor function in a different math question before. A, B, A, C, A, D, A, B. Periodically. So you go A, E next? And then A again? You're doing a lot of A's. Good. I start thinking about the area of boxes made by f of x. Yeah, they change from 1 to 0. Good idea, Anna. Right, let's put chat back on, since I seem to be talking to chat. That's J, I'm afraid. The reason this is hard, which you don't need me to say, is that it's combining together ideas about the following. From the syllabus, area under the line or the curve or whatever is integration. It's got an idea about a geometric series right at the end. It's got ideas about logarithms. It's got powers. So we did some revision a couple of months ago about logarithms and powers, but this does both of them in different ways. It's got ideas about new content, new idea, or new definition. Something new. This is this thing, which people in chat might not have seen before. You don't have to have seen it before. Here's everything you need to know about it, including an example of how it works. It's all of that all at once. And the question just looks really complicated. The way you approach this is to break it down step by step. Like how if you're trying to, in school, if you're trying to graph some tricky function, if someone says, please draw, I don't know, e to the sine of x squared or something, you start by thinking about x squared, then you think about sine x squared, then you think about e to the sine x squared. You do it step by step. You don't just try to draw it in one go from your first guess or something. You try and build it up. And lots of things work like that in real life and in maths. Building things up. Can I explain sequences and series in a nutshell? Yes, good news. I kind of already did that. There's a live stream. We recorded the whole thing. It's on this YouTube channel, in this YouTube playlist. If you scroll back to sequences and series, or if you're on the MAT Livestream website, if you scroll up the page, or from the current row that I'm in the table. Am I in a table? I'm in a table right now. There's a row of the table that we're currently in, a few rows up. There's a thing about sequences and series. If you don't want to see that, there's some flashcards you could get from the MAT Live website that just give you some revision ideas. You could grab the worksheet, have a look at what you're supposed to know. You're supposed to know a thing about arithmetic progressions, a thing about geometric progressions, and that's it. Maybe 2 things about geometric progressions. So you should know the formula n over 2, 2a plus n minus 1d, which at the start of the MAT live stream this year I did not have memorised, but now I do. You should know the formula a over 1 minus r. You should be able to do the other one as well. Let's get one of them wrong just to drive chat engagement. Is it this one? Is this the one that I'm getting wrong? What's the n? I think if there are n terms, because the first one would be r to the 0, so the last one is r to the n minus 1, so the next one would be r to the... Goodness me. Yeah, the infinity stuff. So this is tagline in chat, the infinity stuff. Should label that, shouldn't we, in the infinity stuff. Ruby says, in the longer questions, do we have to leave answers in a certain form, e.g. rationalising the denominator? Generally, no. I'm getting grad students to mark this. They're pretty clever. If the question says to simplify your answer, then have a go. We're trying to spot when people have got the right answer, and if you've got the right answer but there's some extra factors of root 2 upstairs and downstairs, then I feel like you should probably still have the same credit. Is it unusual to not have had an email from the college you applied to yet? Harry, you've got 5 thumbs ups, which means I think that other people haven't got an email from the college you applied to yet. The email from the university mentioned they'll be in touch soon. Behind the scenes, the application database for Oxford hasn't launched. Is that true? I'd give them a bit more time. Nothing's gone wrong. It's just UCAS deadline was only 9 days ago. Give us a bit of time. We're getting there. No reason to panic. Please carry on and do the maths. What am I a doctor in? Well, technically, I did my PhD in applied mathematics. But technically everyone's a doctor in, well, medical doctors are doctors of medicine, but people with academic doctors are technically doctors of philosophy. PhD stands for philosophy doctor, which sounds really stupid. My degree certificate says Doctor of Philosophy, right? That's not really what you're asking. Good. Do I prefer stats or mech? Oh, I like mechanics. Am I going to be an interviewer? Yes. There are lots of people who are interviewing. There are maybe 100 people are doing Oxford interviews. Really a lot of people, with some collaboration and working together and sharing notes and a lot of stuff. But yeah, I'm one of many people doing maths interviews this year. But what percentage of applicants do you interview? About 30% for maths. We interview about 3 people per place. Right, I think I'm now talking to chat. If you want to see maths questions, I think we've done the last one of the MAT live stream before the bonus live streams, so I'll say something about that. Good. I'm going to have work. I just realised interviews take place, given that I'm invited. What should I do? Contact your college to sort out when you could possibly be available, if you're invited. Interview prep live streams after that. Yeah, let's talk about our schedule. Thank you, Shrist, for the great segue into content. Here is my timetable. Oh, goodness me, I should probably log out before I show you this. Not that there's anything bad, just, safety first. Here is the timetable. You can see this on our website, MAT Livestream 2024. It's that website I've been pointing to it. This has got a timetable of some bonus streams. Here's what we're doing next. Next week, no stream. It's the date of MAT 2024. The week afterwards, no live stream. Sorry. But the 14th of November, we're going to be back to do a bit of debrief to talk about MAT 2024. If you're interested. And then week off. Sorry, no live stream that week either. But 28th of November, so coming back in about a month from now. We're going to do a bonus live stream looking at interview questions and talking about the sort of problem solving and other stuff going on in those. So I might see some of you back for 28th of November. You might also be interested in the Oxford Online Maths Club, which is coming back in January. I host it, but I mostly try to get other people on the show to tell us about maths. That is not about the maths admissions test, it's a series of live streams to do some sort of fun maths. It's got a pretty similar visual look, but it's a totally different style of math stuff. If you like maths, then you might like maths content over there. So while we won't be doing math past questions in upcoming live streams, we've got a couple, well, one where we are, because we're talking about MAT 24, one where we're talking about interview questions, and then quite a lot coming up, Oxford Online Maths Club, and next year it's, again, on YouTube, anyone can watch. You don't have to be an Oxford student. There you go. Alistair Myth. Enjoyed this year's Maths Club? Yeah, good. There's a recommendation from Alistair in chat. Are you still streaming on Twitch? Yep. Have I updated the flashcards? I don't think I made any new flashcards this year. But maybe, When do we find out? You find out late November or possibly early December. Everything is a little bit later in the calendar year this year round, so I think I'm going to say early December, maybe a week's notice for interviews. And yes, Imogen, everyone gets their MAT results automatically in an email that's sent out in January. That email has lots of blank lines. It says, don't scroll down if you don't want your MAT score. If you want to see your MAT score, scroll down to the end of this email. There you go. This took a lot of time. Yeah, and Integration Bible says, good luck to everyone. We're doing some wrap-ups now, aren't we? Here we go. You get your results in January. I'm ready very soon. Get ready for preparation. Yeah, so I've kind of tried to do that all the way through, Rishi, but I think my main advice is make sure you know the maths on the syllabus, make sure that you're willing to work on unfamiliar problems, ready to be surprised, and then overcome that by hitting it with things from the syllabus, or hitting it with your logical problem solving skills, or general ability to learn new things in a question that's showing you something new like this one. And maybe look at the practice test on the website to get a feel for the format of the test and what's going to happen in the test room. Good luck, everyone. I am also sure you're going to smash it. Tips for preparation. Do I know if I don't get invited to interview, or will I just be waiting for you? Oh yes, we send both sorts of email. So if you're not invited to an interview, we don't just go quiet. You get an email from the college saying, really sorry, but straight the field, you're not going to be invited to interview this time round. Okay. Oh my goodness, look at this. Best way to revise for next week. Don't overdo it. Don't overdo it. You're not trying to predict the questions that are coming up. You're not trying to get in the place where all of the past questions are in your head and you can just see the same question again. The questions every year, you'll have noticed the questions are different to the previous year. You're trying to get happy that you can do unfamiliar things. Last episode before test, but we've tried to point you towards other things. Other YouTube channels are available. Other live streams are available. Good, right, okay. Any content you recommend for the MAT? If you've done all the past papers, I suppose you could look at TMUA, couldn't you? Or even STEP questions. Or you could revise A-level. Write your own MAT questions. Based on past questions if you like, but write your own. See if you can do better than that thing in question 4, because what was going on there? Maybe you can write your own questions, and then if you do really well at that, then you're a mathematician now. There you go, you did it. You're inventing new things. Have fun. And there's a question about approaching series and sequences. I have 2 hours of sequences and series on the YouTube channel. Not live, I'm afraid, anymore, but if you scroll back, there is 2 hours of sequences and series, how to approach those questions. We have this content, but I'm going to stop streaming in a minute. But in some sense, you can keep watching the live stream from days gone by. Ooh, that's a weird note to end on. Let's do something better. Yep, see you next year. I hope it goes all right next week. If you're completely stuck, look at a different question. If you're only stuck on one question, then congratulations, you've had a great test experience. If you're stuck on 2 questions, switch between them. And thank you for coming along. I could technically do these live streams without you, or only as recorded videos that nobody sees live and people just watch afterwards. I could technically do that, but I don't think it would be very good. So thank you, people who've been joining in live and joining in chat. Helped us choose which questions to do, helped us answer them, and generally helped along the way. You've helped yourself more than I could ever help you. Right, good. Okay, I think I'm wrapping up. Oh my goodness, there's a lot of chat going on suddenly. This is where Callie is approving chat at a rate over Callie's never had to approve chat for. Thank you, Callie. Right, okay. Take care, everyone. Remember, you can contact your test centre, you can contact customer support in Pearson, you can even contact us. There is a contact button if you want to get in touch on the MAT Live page. Let's just hope everything doesn't need to. Just hope they don't need to contact anyone. Just do the maths. There we go. Let's end on that. Let's end on that note. I'll write it on the screen. Do the maths. Okay, right. Enjoy it if you can. I will see you afterwards for another episode at some point in the future if you come for the bonus episodes or in the Oxford MAT Maths Club. Bye.